Hello class, welcome to section 9.6, last section of chapter 9, which is on annual percentage rate, as you can see. A few definitions. Annual percentage rate is what's considered a true interest rate, where we consider the interest earned over a year. And it's in opposition to some of the other instances and situations we've been talking about, such as add-on interest, where we calculate interest per month, interest for a certain smaller period. So annual percentage rate is, of course, the interest rate over a year. And again, what's considered the true interest rate. Finance charge is the amount paid by a borrower to use money. Basically, this is another word for interest on a loan, and occasionally will include fees. So, for example, if you had a $20,000 car loan, you calculate that in total, once you add up all your payments, you paid $34,130 for it. So your finance charge is the difference between the two values, which in this case is $14,130. So that's what a finance charge is, and they're used in this section to help us find the APR given a certain interest rate. So let's take a look at a few examples. Now, one of the ways you'll find an APR in this section is to use the chart on page 440. That's what this first example will do. And one of these examples, the more common one, is using the approximation formula that you'll see here in a minute. So, for example, Daisy's agreed to pay off a $4,500 loan by making 24 monthly payments. The total finance charge is $600. Using this chart I refer to, find the APR. And if you look at the chart, it's going to ask you to, first of all, how many monthly payments. Now it's given to you, 24. Now it's also going to want to know what the finance charge per dollar is. And to do that, we take the finance charge divided by the amount borrowed, $600 divided by 4,500, which comes out to be 0.1333 repeating. So to find out the actual amount, we have we multiply times 100 and 1333. Using the chart again on page 440, we approximate where is the closest that it comes to. In that row of 24 payments, what's the closest amount given to 1333? And it's about 1289. Which, if you go straight up, you see corresponds to a 12%, or approximately a 12% APR. So in these types of problems, it's a matter of finding the finance charge divided by the amount borrowed, multiply times 100, then use that amount on your chart, find the number of payments, and then find approximately what percentage that falls under. And as you can see, if you're looking at it, it's a fairly small chart. So there's not a huge range that you would find. Just interest rates from around 11% to about 14 or so. The other formula that I'll be having you use is our approximate APR formula, where the APR is equal to 2NR over N plus 1, where R is the interest rate, the annual interest rate, and N is the number of payments. The number of payments means that over the course of a particular loan. So in other words, assuming you pay monthly, if you have a 2-year loan, that's 24 payments. If you have a 3-year loan, that's 36 payments, and so on and so forth. So a common question I could ask you would be, for example, Mary borrows $3,200 for college tuition, gets a loan for 6.5% for 4 years, with monthly payments. What is the approximate APR? So annually, what's the percentage rate that she would get? According to our formula, we have 2. The number of payments overall. So 4 years paid monthly is 12 times 4, or 48 payments. Times our rate, and remember that rate is always a decimal, in decimal form. so 0.065, divided by n plus 1, so 49. And when you do that, and when you multiply times 100, you'll get about 12.7%. And with these, I tend to round to the first decimal place. So another one. Aaron has a 8.72 loan, or percentage loan, with monthly payments, for 5 years. What is her approximate APR? Now you notice in this one, I didn't give you a dollar amount because we don't need it. You don't need to find the APR. All we need is the loan and the number of years that we have it. In this case, again, 2 times the number of payments, which is 12 times 5, 60, times our rate as a decimal, divided by n plus 1, comes out to be about 17.2%. So this concludes section 9.6. As always, if you have any questions, feel free to contact me, and have a good day.